Students, we are discussing chapter enzymes, right? Okay, now in this chapter enzymes, right, go for the next topic, that is how do enzymes bring about such high rates of chemical conversion. Okay, this is the topic name, right? Sir, what is the meaning of chemical conversion or metabolic conversion? What it is? Chemical conversion. Chemical conversion. Chemical conversions or metabolic conversions. Chemical conversions or metabolic conversions. Sir, chemical conversions or metabolic conversions means nothing but reactions. Nothing but what, sir? They are reactions. Sir, during these reactions, substrate is converted into product. Therefore, during what? Reactions. During what, sir? Reactions. During reactions, okay, what is converted into what, sir? Substrate. What, sir? Substrate is converted into product. Substrate is converted into product. Sir, substrate is represented by S, whereas product is represented by P. Okay, therefore during a reaction, what is converted into what? Substrate is converted into product. Sir, what is the meaning of a substrate? A chemical which is converted into product during a reaction. That chemical is called as a substrate. What is that chemical called as? Substrate. Therefore chemical which is converted right into product, which is converted into product during a reaction. Therefore during a reaction, the chemical which has converted into product, that chemical is called as what, sir? That chemical is called as a substrate. That chemical is called as a substrate. Is this statement okay? Now listen here. Sir, substrate can be converted into product. Substrate can be converted into product even in the presence of enzyme. Okay, even in the absence of enzyme also. Therefore, substrate converted into product. Substrate converted into product in absence of enzyme. Absence of what, sir? Enzyme. In the absence of enzyme. Number 2, presence of enzyme also. Presence of enzyme. Presence of enzyme. Sir, substrate is converted into product. Yes or no? Substrate is converted into product even in the absence of enzyme. Then why we have to use the enzyme, sir? Why we have to use the enzyme? Because this enzyme speed ups the rate of the reaction and decreases the activation energy required. Okay. Therefore, what enzyme is doing in a chemical reaction? What enzyme is doing in a reaction? It increases the rate of the reaction, decreases the activation energy required. Okay, sir, substrate converted into product. Okay, even in the absence of enzyme. Even though this reaction can take place in the absence of enzyme, then why we are using enzyme in this reaction? Because enzyme speed ups the rate of the reaction, decreases the activation energy. Therefore, write enzyme. Enzyme in a chemical reaction. Enzyme in a chemical reaction or enzyme in a reaction. What it does? What enzyme is doing in a reaction, right? Increases rate of the reaction or speed ups the rate of reaction. Okay. Number 2, decreases activation energy. Decreases what, sir? Activation energy. Therefore, enzyme increases the rate of the reaction, decreases the activation energy, right? Now, listen here. Sir, this is a enzyme. What is this? This is a enzyme. This is a enzyme. Okay. Sir, in this enzyme, this is what? Active site. What is this one? Active site. This is a active site. Okay, right? Now, this is a substrate molecule. Okay, this is also a substrate molecule. All these are substrate molecules. Okay, right? Therefore, all these are which molecules, sir? They are substrate molecules. They are substrate molecules. Substrate molecules. Okay. Now, during a reaction, what happens means these substrate molecules they diffuse us towards active site of the enzyme. What are diffused? Substrate molecules are diffused towards active site of an enzyme. Then what happens? This substrate comes and binds in the active site of an enzyme. What has binded, sir? Substrate has binded. Where? In the active site of an enzyme. Substrate has binded in the active site of an enzyme. What has binded, sir? Substrate has binded in the active site of an enzyme. Substrate has binded in the active site of an enzyme. See, the substrate has binded in the active site of an enzyme. So what is formed, sir? Enzyme substrate complex is formed. What is formed, sir? Enzyme. Enzyme what? Substrate. Enzyme substrate complex is formed. Enzyme substrate complex is formed. I am writing the shortcut of this enzyme substrate complex. Enzyme substrate complex. Enzyme substrate complex is formed. Okay. Sir, this enzyme substrate complex, this complex, formation of this complex is obligatory. Obligatory, compulsion. In which reactions? Reactions which are catalyzed by enzyme. Sir, if a chemical reaction, okay, if a reaction takes place in presence of enzyme, reactions which takes place in presence of enzymes, in such reactions, formation of enzyme substrate complex is obligatory, compulsion. Therefore, write enzyme substrate complex, write formation, right, is obligatory, compulsion. In which reactions? Enzyme catalyzed reactions. I am not saying about reactions in which enzymes are absent, enzymes are not participating. Reactions in which enzymes participates, enzyme catalyzed reactions. In enzyme catalyzed reactions, formation of enzyme substrate complex is obligatory. Sir, this enzyme substrate complex, okay, it is unstable. Stable, unstable, it's unstable. It's unstable. Sir, it's transient, temporary. Transient, temporary. Therefore, enzyme substrate complex formation is obligatory in enzyme catalyzed reactions. This complex is unstable, it's transient, temporary. Sir, what happens? See, once a substrate binds in the active site of the enzyme, okay, the bonds present in the substrate are broken and new bonds are formed. Therefore, breaking and making of bonds. Due to this breaking and making of bonds, the substrate gets changed to product. Okay, once a substrate binds in the active site of an enzyme, okay, what happens, right? The bonds present in this substrate, are broken and new bonds are formed, by which the substrate changes into transform converts into what? Product. Therefore, now in the active site, what we are going to get? In the active site, we are going to get the product. What we are getting in the active site now, sir? Product. We are going to get product in the active site now. Okay, right? What we are going to get now here? Product. Sir, this is a product, sir. This is another product. Okay, now what is this complex called as enzyme product complex? What it is called as, sir? Enzyme product complex. Enzyme product complex. Enzyme product complex. What is the shortcut, sir? Enzyme product complex. Enzyme product complex. Okay, now what happens? Now slowly this product it comes out of the active site of the enzyme, because as its structure is different. Whose structure? Product structure is different, right? The active site cannot bind the what? Product. So this product comes out of active site of an enzyme. Sir, once this product comes out of active site of an enzyme, what comes out of active site of an enzyme, sir? Product. Once the product comes out of active site of an enzyme, what becomes free? Enzyme molecule becomes free. What becomes free, sir? Enzyme molecule becomes free. Is it okay? Sir, in a chemical reaction, okay, how enzyme has participated, sir? Right, see here. Substrate binded in the active site of the enzyme. Strictly speaking, this substrate diffuses towards the active site of an enzyme. Then substrate binds in the active site of an enzyme, forming enzyme substrate complex. Its formation is obligatory in enzyme catalyzed reactions. This enzyme substrate complex is unstable, it's transient, temporary. Why, sir? Because it has changed to enzyme product complex. No, so I told it's transient. Okay, right? Sir, once a substrate binds in the active site of an enzyme, right, the bonds in this substrate are broken and new bonds are formed, by which the substrate gets changed to product. Therefore, now what is formed? Enzyme product complex is formed. Enzyme product complex is formed. Enzyme product complex is formed. Okay, right? Sir, this enzyme product complex, right, once product comes out of active site of an enzyme, the enzyme becomes free. The quality of the enzyme, the quantity of the enzyme remains unchanged. See here. How the enzyme, how many enzymes entered this reaction? Only one. How many? Right, we got finally, right, only one. Therefore, is there any change in the quantity of the enzyme? No. Similarly, no change in quality of the enzyme also. It means how an enzyme entered a reaction, right, the enzyme comes out of the reaction like that only. Therefore, quality of the enzyme, quantity of the enzyme remains unchanged. Quality and quantity of the enzyme remains unchanged. See here. Sir, this is okay, enzyme. What are these, sir? Substrates. This is enzyme substrate complex. This is enzyme product complex. What is this one, sir? Product. Yes or no? Right? Sir, substrate is stable. Substrate is stable. In between stable substrate and product, we got right, we got many intermediate structural states. Okay, intermediate structural states which are altered, which are changing from one to another. Yes or no? Therefore, in between what, sir? In between right, stable, in between stable substrate, in between stable substrate and what, sir? In between stable substrate and product. In between stable substrate and product, we got what's our intermediate structural states. We got what's our intermediate structural. We got intermediate structural states, altered structural states. Nothing but enzyme substrate complex, enzyme product complex, which are unstable. Sir, substrate is stable. In between the stable substrate and product, we got many intermediate structural states or altered structural states which are unstable. Sir, stability, it is something that is related to energy of a molecule or a structure. Therefore, how you are saying that it's stable? Stability is related to what, sir? Energy. Therefore, stability is something that is related to energy. Related to energy of a molecule. Related to energy of a molecule or structure. Okay, right? Right? Stability. Stability is something that is related to what, sir? Energy. That is related to what, sir? Energy. Related to energy of a molecule or structure. Okay. Now listen here, sir. In a reaction, okay, right? In a reaction, right? Substrate has converted into product, sir. What is converted into what, sir? Substrate is converted into product. For example, right? This substrate. For example, this what, sir? Substrate. This substrate, right, it is having, right, 1000 kilocalories of energy. This substrate is having how much amount of energy? 1000 kilocalories of energy it is having. When the substrate is converted into product, for example, this product, it is having only 400 kilocalories of energy. For example, it is having only 600 kilocalories of energy. See this reaction? Sir, substrate converted into product. Substrate is having 1000 kilocalories of energy, whereas a product is having only 600 kilocalories of energy. Yes or no? Having only 600 kilocalories of energy. Actually, the substrate is having how much? 1000 kilocalories of energy. It means right now 400 kilocalories of energy has came out during this reaction. During this reaction, how much amount of energy has came out? 400 kilocalories of energy has came out. Sir, your energy is released or absorbed, sir. Energy is released. These reactions are called as exothermic reactions or exergonic reactions or spontaneous reactions. What are these reactions, sir? Exothermic. Exothermic reactions. Exothermic reactions. Exothermic reactions are exergonic reactions. Exergonic reactions are spontaneous reactions. Spontaneous reactions. Sir, in exothermic reactions or exergonic reactions or spontaneous reactions, what happens, sir? Energy is liberated. Energy liberated. Energy is liberated. Okay. Sir, in these reactions, the product is having less amount of energy than its substrate. Yes or no? Therefore, product having what, sir? Less amount of energy. Product is having less amount of energy than its what? Substrate. Than its substrate. Therefore, than its substrate, the product is having less amount of what, sir? Energy. Okay. Now listen this statement. Sir, what is the meaning of endothermic? Endothermic reactions. Name itself indicates endo means inside. Okay. Sir, endothermic reactions are also called as right, endergonic reactions. Endothermic reactions are also called as endergonic reactions. Sir, they absorbs energy, utilizes energy. Therefore, energy utilizing reactions. energy utilizing reactions. Now should be very careful whether it is exothermic reaction or endothermic reaction. Whether it is exothermic reaction or endothermic reaction, before substrate converts into product, before substrate is converted into product, the substrate has to move from ground state to excited state. Ground state to excited state. That excited state is called as a transition state. What is that excited state called? As a transition state. Transition state, right? Now listen here. Therefore, either what? Either exothermic or endothermic. Either exothermic or endothermic reactions, right? Before what? Before substrate converted into product, substrate has to move from where to where? Substrate has to move from where to where, sir? Ground state to excited state. What is this excited state called? As a transition state. Excited state is also called as a transition state. Okay, now listen here, sir. This is a substrate, sir. First, this substrate, right, it has to move from where to where, sir? It has to move from ground state, has to move from ground state to which state, sir? Excited state. This is excited state, that is a transition state. Sir, this is lower energy level, this is higher energy level. Yes or no? Right. Sir, ground state, lower energy level. Yes or no? Lower energy level. Lower energy level. Sir, transition state, excited state, it's what, sir? Higher energy level. It indicates that right, substrate at ground state, right, substrate at transition state having different energies in it. Having different energy in it. Yes or no? The difference between energy of a substrate at ground state to energy of a substrate at a transition state, this difference in energy is called as activation energy. What is this difference in energy called? As a activation energy. Therefore, what is the meaning of activation energy, sir? What it is? Activation energy. Therefore, activation energy means difference in energy. Difference in energy. Difference in energy between substrate at ground state to substrate at transition state. Transition state. This difference in energy between substrate at ground state to substrate at a transition state, right, this difference in energy is called as activation energy. Sir, in the absence of enzyme, more activation energy is required. Absence of enzyme, more activation energy is required. Whereas presence of enzyme, less activation energy is required. Presence of what? Enzyme, less amount of activation energy is required, right? Now see this graph once. Sir, in this graph, substrate level is high, product level is low. It means substrate is having more amount of energy than its product. Therefore, this graph indicates which reactions are exothermic reaction, because substrate with more amount of energy, product with less amount of energy. Therefore, this is an exothermic reaction. Exothermic reaction. Sir, if you see this graph carefully, right here two graphs are there, 1 and 2, yes or no? Sir, I am calling this one as graph 1, this one as graph 2. Okay, see here. Sir, this is graph 1, sir. What is this one, sir? Graph 1. Here more amount of activation energy is required. See, sir, what is the meaning of activation energy? Energy difference between a substrate at ground state to substrate at a transition state. See, this is a substrate at ground state, this is substrate at transition state. What is this difference in energy called as activation energy? Absence of enzyme, more activation energy is required. Presence of enzyme, less amount of activation energy is required. Therefore, absence of enzyme, more amount of activation energy. Presence of enzyme, less amount of activation energy. Therefore, enzyme brings down the activation energy that is required for a reaction and makes the conversion of substrate to product more easier. Makes the conversion of substrate to product more easier. Who is bringing down the activation energy that is required, sir? Enzyme. Enzyme brings down the activation energy that is required for a reaction and makes conversion of substrate to product more easier. Okay, right? Formation of a enzyme substrate complex. Formation of enzyme substrate complex. What is formation of enzyme substrate complex? Formation of enzyme substrate complex. Enzyme substrate complex. Formation of enzyme substrate complex right was explained by right, number 1, lock and key hypothesis. Lock and key hypothesis. Lock and key hypothesis. This lock and key hypothesis was proposed by Emil Fischer. Proposed by Emil Fischer. Sir, number 2. Second one is induced fit theory. Induced fit theory. Induced fit theory is proposed by Koshland. Sir, in this this lock and key hypothesis was first proposed, right? This induced fit theory was proposed later. Okay, sir, what is this lock and key hypothesis? Lock and key hypothesis. A particular lock is opened by a particular key. A particular lock is opened by a particular key. Similarly, enzyme is having some specific sites. Enzyme is having some specific sites. What are the specific sites called as active site? Sir, in this active site only a particular substrate can bind. Only a particular substrate can bind. See this diagram. Sir, this is an enzyme having a specific site called as active site. In this active site, right, only a particular substrate can bind. Only this substrate can bind. This cannot bind. Sir, why only this? Why not this, sir? Because its structure is similar to the structure of the active site. Therefore, substrate whose right structure is similar to the structure of active site, only that substrate binds in the right active site of an enzyme. Therefore, have a particular lock opened by a particular key, right? Enzyme is having some specific sites in which a particular substrate only can bind. Particular substrate only can bind. Therefore, this hypothesis accounts for enzyme specificity. This hypothesis accounts for enzyme specificity. Okay. Now go for the second one. What's our induced fit theory? What is our induced fit theory? See here, sir. This is an enzyme, sir. This is an enzyme. Okay, sir, this is what's our active site. What it is, sir? It is an active site. It is an active site. Okay, sir, for example, right, substrate, it has binded in the active site of an enzyme. Once a substrate binds in the active site of an enzyme, this substrate induces a conformational change in the right active site. Due to this conformational change, where, sir? Due to conformational change in the active site of an enzyme, now the active site binds the substrate molecule tightly. It means now the substrate has tightly binded in the active site of an enzyme. How, sir? See here, sir, substrate binded in the active site of the enzyme. Then what substrate did? It induced a change, a conformational change in the active site of an enzyme. It means once substrate binds in the active site of an enzyme, right, this active site undergoes a conformational change. Due to this change in the conformation, now the active site binds the substrate molecule tightly. It means now the substrate fits tightly in the active site of an enzyme. Induced fit theory. Okay, who is inducing? Substrate molecule. What it is inducing? A conformational change, where in the active site of an enzyme, by which what happens? The substrate fits tightly in the active site of the enzyme. Right? Note. Number 1, feedback inhibition. What it is, sir? Feedback inhibition. Feedback inhibition. Sir, take a series of chemical reactions. What, sir? Series of chemical reactions. Sir, series of chemical reactions means what, sir? See here. A is substrate. It's converted into B. In presence of one enzyme by name E1, sir, in this reaction, A is substrate, B is product. Sir, this B is converted into C. B is converted into C. Therefore, now B becomes substrate and C becomes product. In presence of an enzyme by name E2, sir, C is converted into D. In presence of an enzyme by name E3. See here, sir, in this reaction, A substrate, B product. In this reaction, B is substrate, C is product. It means product of one reaction is becoming substrate for another reaction. Product of one reaction is becoming substrate for another reaction. These are called series of chemical reactions. In a series of chemical reactions, when end product, this is the end product, finally what we got. Okay, when end product accumulates, when this end product will accumulate, if its concentration is more, then this end product inhibits the enzyme of first reaction. End product inhibits the enzyme of the first reaction. This is called feedback inhibition. Therefore, in a series of chemical reactions, when end product accumulates, it inhibits the enzyme of first reaction. This is called feedback inhibition. Sir, here who is inhibiting the enzyme of the first reaction, sir? End product is inhibiting the enzyme of the first reaction. So, feedback inhibition is also called as what's our product inhibition. It is also called as a retro inhibition, product inhibition or retro inhibition. Product inhibition or what's our retro inhibition. Best example for feedback inhibition. Best example for feedback inhibition is inhibition of hexokinase enzyme. Inhibition of what? Hexokinase. Inhibition of hexokinase enzyme. Inhibition of what, sir? Hexokinase enzyme. Inhibition of hexokinase enzyme by glucose 6-phosphate. By what, sir? Glucose 6-phosphate. What is inhibiting what, sir? Glucose 6-phosphate is inhibiting hexokinase enzyme. This is an example for feedback inhibition, also called as product inhibition or retro inhibition, right? Number 2. We are discussing some important statements in note, right? First one, feedback inhibition. Number 2, see here. Sir, in presence of competitive inhibitor, Km value increases, but no change in Vmax. Sir, in presence of non-competitive inhibitor, Km value does not changes, but Vm decreases. Sir, allosteric modulators does not obey, sir. Okay, right. In presence of allosteric modulators, what happens? Sir, allosteric enzyme, they does not obey Km, sir. Allosteric enzymes, they does not obey Km. So, no change in Km even though allosteric modulators are present. Therefore, even in the presence of allosteric modulators, no change in Km for allosteric enzymes, because allosteric enzymes does not obey Km. So no change in Km even in the presence of allosteric modulators, right? Thank you.